So this is for the forces in a circular motion standard, and in this problem we have a 95-kilogram halfback who makes a turn on the football field. He sweeps out a path that is a portion of a circle with a radius of 12 meters. The halfback makes a quarter of a turn around the circle in 2.1 seconds. So we're trying to find the speed, his acceleration, and the net force on the quarterback. So not really sure how a lot of football plays work, but here we have the 95-kilogram quarterback, the radius of 12 meters, and the quarter of the turn in 2.1 seconds. So we know his mass, we know the radius, and we know a fourth of the circle time. We're trying to find the velocity, the acceleration, and the total net force on the halfback. So for the velocity, we're going to use the equation velocity equals distance over time. So for the distance, since it's a circle, we're going to have to use circumference. So we're taking 0.25, which is the fourth, times 2 pi r, which is the circumference equation, over t, which comes out to 18.84 meters over 2.1 seconds, which is going to have a velocity of 8.97 meters per second. So now with the velocity, we can find the acceleration. So the acceleration for a circle is the velocity squared over the radius. So we just found the velocity, which is 8.97 meters per second over 12 meters. So we squared the velocity to get 80.46 meters squared per second squared divided by meters to give us an acceleration of 6.71 meters per second squared. Now the last portion of the question asks us to find the total net force. So the equation for the net force for a vector is mass times the acceleration. So we know his mass, which is given to us, is 95 kilograms. We just found the acceleration, which is 6.7 meters per second squared, which is going to give us a total of 636.5 newtons.